Hi, and welcome to Mike's Garage. Got a great video for you today. So today we are actually going to power this up. So as you know, this build is to power my house, in which got 3 inverters, a whole bunch of batteries. And so the DC side is connected. Haven't done the AC yet, haven't done the panels, but all the batteries are connected up, all the bus bars, all the T-class fuses, and all the inverters. So we're going to power it on together. Fingers crossed everything's good. Everything is torqued down the spec, so we should be good to go, but we're going to power it on together. One thing real quick before I give you a real brief overview of the system and power it on, if you haven't checked out windsolarforum.com, that is the forum for this particular channel or anybody else that is interested in DIY solar or wind. So let's go ahead. Let's do that overview and get things powered up. I'm excited. Hopefully you guys are as well. All right, so we're going to start with the battery. So we do have 18 of these Vatra batteries all connected up in parallel. So you have a set of three, so on and so forth going down the line. Each one of these is 100 amp hours. So it's a lot of capacity. So I have 18 of those set up. I also have these eco-worthy floor standing batteries. These are 280 amp hours each. I have 3 of them set up. As far as cabling real quick. So I went overboard on cabling, and that's what I always do. And you can see my bus bars are kind of overkill as well. But I actually I had to grind down the lugs just slightly to make it work. But I have 2-aught cable connecting this whole thing up. So all these cables here going all the way up to the bus bars, it is all 2-aught cable to ensure that everything is balanced quite well, but also that, it's as efficient as possible. As you know, the high voltage systems are a bit more efficient, but this system I've been looking forward to building for quite some time, and it's going to get more goodies as well. I plan on adding some additional batteries. So it is 135 kilowatts of batteries, or kilowatt hours of batteries. So it's a good amount for now. All right, so back to this. So you have your 2-aught cable goes up, and each one of these has their own T-class fuse. And the reason for that is, as you're connecting all of these batteries together, you do not want to have a shorted BMS and have an inrush into it from all the other batteries. That would be very, very bad. So each stack has its own T-class fuse. So it is a UL listed T-class fuse. It is by South Bend. These are 225 amps. And you can see how I have this covering. So I have this sleeve over each one of the positive cables. It is UL listed. It's not really made for what I'm using it for, but if there's any, sharp corners or anything like that, like you can see on these brackets down here, got a little bit of a sharp edge, So I wanted to make sure that it's safe. So I put sleeves on all the positives. Anyway, so goes up to the 2-aught cable, and then goes up to the T-class fuse for each of these 3 here. And then it's going to go into my bus bars. These can handle a tremendous amount of power, around 1,350 amps on the low side. I think that's around 60 degrees Celsius. But if you're going to rate it higher than, 15, 16, 1,700, what have you, more than I would ever need. But as you can see, all of this is all overkill anyway. So goes up to the bus bars. And you can see I have 2 4-aught cables. You're going to love this. So one 4-aught cable comes out, goes into this T-class fuse, and then into the inverter. That way, if I have an issue with the inverter, this will blow. This will, save me. And then I have another 4-aught cable, which goes all the way across and connects to this bus bar. So kind of stepping back, each one of the positive bus bars are connected together with 4-aught cable. Each one of the negative bus bars are connected with 4-aught cable. So if I wanted to, say, put more batteries over here, all I got to do is add a few more bus bars, and I can just keep on extending the system out, and I won't have any balancing issues. All right. So once again, I've got my 4-aught. It goes up, goes into this T-class fuse, and then into the inverter. All right. So here's kind of what it looks like. And then for the output, it's not wired up yet. I was just kind of messing with my conduit, and I've got all of them going across, and then they're going to go into my combiner panel here. So it should look pretty cool. I know it might look a little bit chaotic. Might be a good word, or you can use a lot of good words you can use. Anyway, you might say it's busy. We'll use busy, that there's a lot of cables and it is busy. But I wanted to make sure that it was set up as efficiently as possible and also that it would be as balanced as possible. When I say balanced, if you look at these eco-worthy batteries, which are 280 amp hours, and you have uh, essentially this is one big battery that's 300 amp hours, your 280 amp hour battery should charge and discharge faster than the other ones because they're different sizes, two different sizes. So on this one, I did add an extra foot of positive and negative to compensate. If it's not needed after charging and discharging a bunch of times, and it seems like this one is now lazy compared to the other ones, then I will shorten it up to the length of the other ones. But I wanted to try to do whatever I could to balance everything. Now, when I go to power these on, they're at roughly 50%. And before I truly use this system, what I am going to do is I'm going to charge each battery separately up to 100%. So essentially, you would flip on the breaker and charge that particular battery with all the other breakers off, and then just kind of do one at a time till I get all of them at 100. And then once they're all completely filled, then everything's balanced. All right. Now, the fun part, this is what I've been looking forward to, is powering this on. So I can flip on a battery and I can use a resistor to try to kick it off. Or these eco-worthies, they do have pre-charged resistors from what I'm told, but this is the first gen of this battery, and I don't know if I want to trust it for that. So I'm using one of my nice power supplies, and I'm going to connect it to the bus bars, and I'll have it set at 55 volts. And then I'm just going to slowly turn up the amperage, which essentially will power these all up very, very nicely. So let's go ahead and do that. So we'll do positive to positive, negative to negative. Like I said, all these are connected in 4-aught, so it really doesn't matter where you power it. Everything is being powered up. Okay. So now, first thing we're going to do is we're going to turn on our output. And as I'm turning this up to 3 amps now. Looks like the watts are steady at 50 watts. Okay. Yeah, and here they go. They're all starting up. So if memory serves me correct, I should have a nice yellow ring instead of the green ring that I have on that one, because I need to set up in lead acid mode, whereas by default it is in SOC mode and trying to communicate with batteries that don't have communication set up. So here's what it's showing so far. It's showing 0 battery voltage because it doesn't know, because I've got to set it up for lead acid. But they are all powered up. So you can use a power supply to power on your inverters. It's a nice way of doing it. You can slowly ramp up your amperage, and there we go. The spinning yellow circles. So I believe it's probably going to be code 00. Yes, warning 00. And what that is saying is that it has no clue what the batteries are because it's looking for communication that does not exist. All right. So now we'll flip on all these batteries. So we're at 55 there. Right, I'll power all these on. Remember, right now it's being powered by that power supply. As these batteries turn on, then they're going to, each one of them is going to send power, but there's not going to be an inrush because the inverters were already at 55 volts. So turning it on this way does not hurt a thing. All right. So there you go. It is fully up and running. So next video is probably going to be wiring up the AC section. I also need to do an update on all the inverters, and I need to set up the capacity on them and set it up for voltage, which is basically lead acid mode instead of SOC mode, which is the default configuration. So hopefully you guys enjoyed this video. I know I enjoyed making it, and I am very, very happy that this is up and running and the inverter's powered on as they should. So that's about it. Thanks again for watching Mike's Garage. Please like, subscribe, and leave a comment.